Well, we look at a question which was taken 23rd of August. That is, the paper is CASNEB, CPA foundation level, CIFA foundation level. The paper is quantitative analysis, which was taken on Wednesday, 23rd August 2023. It was a morning paper. And the question that we want to consider today is question 4. Question 4 reads, explain the following terms as used in Markovian analysis. Transition matrix, 2 marks. Equilibrium state, 2 marks. And then initial probability vector, 2 marks. Then the following payoff matrix was developed by a company showing profits in shillings obtained from launching 4 different products, P1, P2, P3, and P4, under 4 different states of nature. So we have the states of nature, state 1, state 2, state 3, state 4, with the corresponding probabilities 0.30, 0.40, 0.20, and 0.10 respectively. Then we have the products. We have product 1, product 2, product 3, product 4. We are required to advise on the best course of action using the minimax regret criterion, 4 marks. Then advise on the best course of action, advise on the best course of action using the expected opportunity loss criterion, 4 marks. Then Roman 3, an expert has offered to provide perfect information at a cost of 2,500. Advise the management of the company on whether or not to acquire the perfect information, 6 marks. So that's the question, and we consider the solution as. Now we have part A. Part A, we are having the 3 terminologies. Under these terminologies, we find them in Markov analysis. Markov analysis is mostly we find it in what we refer to as stochastic processes. And so a transition matrix is a matrix that describes the probabilities of transitioning from one state to another in a Markov process. Now, each element in the matrix represents the probability of moving from one state to another. An example we can consider is if you were to consider the floor. The floor that you, consider a particular building where a lift operates up and down. Then you'd want to consider the floor that you can find the lift at any particular time to be the outcome. So the probability that you find it in a particular floor, if say there are 4 floors, so the probability that you find it in in the first floor having come from ground floor, or it's on the first floor having come from the second floor. So that way of transitioning, moving from one point to another, is what we refer to as transition matrix. Another case where we can have transition matrix is where we can look at the switching patterns of employees in terms of job promotions, etc. So there's a point where one joins, and then where one is promoted, and then where one exits. Those are states. So considering probabilities of having to move from a particular level to another, or from one job group to another, we refer to that as a transition matrix. So the matrix that defines those probabilities of having to move from one state to another is what we refer to as the transition matrix. Now, equilibrium state. As much as this particular process is oscillating, if it's a lift, it has to move from one point to another. As much as that is happening, then we want to believe that there is some point of rest, a state where the system remains constant over time. In other words, the probabilities of being in different states do not change as time progresses, indicating a stable system. In other words, the chance of being in any floor remains constant over time. Then initial probability vector. This vector contains the probabilities of the system being in each state at the starting point, say times 0. It sets the stage for analyzing the Markov process. So like I gave the example of a lift, and considering the floor that you can find it at each particular time, then initial probability vector will give us the probability of the lift being in each floor at the starting point. So that is what initial probability represents here. So we'll see in part B, we'll see how we incorporate it, because we have various states. There are 4 products we are considering in 4 states. And these states have their probabilities defined as state 1, 0.30, state 2, 0.40, state 3, 0.20, and state 4, 0.10. So let's see what let's see how we make use of initial probability vector to find our solution in a decision theory problem. Well, we consider this particular question, and as we have seen, this is 2023. It was taken 23rd of August, and this is quantitative analysis. And the paper, the examination body is KCSE, as we have seen. The paper is done by both 2 groups, that is certified public accountants and certified investment and financial analysts. So the question that we want to consider is a question that we find in question 4, as we have seen. So part A is done, and now we consider part B. The payoff matrix was developed by a company showing profits in shillings obtained from launching 4 different products. So what we see, we are given the table. So we have, let me say we have product 1, product 2, product 3, product 4. Then we have state of nature, state 1, state 2, state 3, state 4. Those are the states of nature. So let me just see what we have here. I hope that can serve us for now. As much as my lines are not straight, I didn't use a ruler, but we can see what we have. So we are told, okay, these are the states of nature. These are the states of nature, and these are the products. So we have product 1, product 2, product 3, product 4. And the entries we see 5,000, 7,000, 10,000, 14,000, and here 9,000, 4,000, 8,000, 5,000. Here we have 7,000, 6,000, 9,000, 7,000. We have 8,000, 12,000, 7,000, 6,000, 6,000, 6,000. So that's the table that we have, and it is the payoff matrix. And we are told, we are given that the probabilities for S1, S2, and S3 are given as, so I would just want to give it in a row form, a row vector form. So that's the initial, so this is the initial probability, and the initial probability is what we refer to as, we give it in a in a vector form. So I have S1, S2, S3, S4 being equal to 0.3, 0.4, 0.30, 0.40, 0.20, and 0.10 respectively. So that's the initial probability vector. This is the initial probability vector. That. Then advice on the best course of action using the minimax regret criterion. Minimax regret criterion. So the minimax regret criterion, what we'll need to do is to actually it involves computing the regret matrix, and where the regret is the difference between the maximum possible payoff in a state of nature and the actual payoff for a given product in that state. So I will first identify in each state, because we have states 1, state 2, state 3, state 4. In each state, we select a product with the highest payoff. So that will be 14,000. Here it will be 9,000. Here it will be 9,000. And here it will be 12,000. So effectively what we need to do is now to get the new entries upon taking care of the maximum payoffs. So I'll be having here again P1, P2, P3, P4, S1, S2, S3, S4, like that. Yes, that's what we have. But then now what I'll be doing is that each time I subtract the maximum from each entry in that particular state. So I'll be having here 0 and here. So it's 14,000 minus 14,000 is 0. Then 14,000 minus 10,000 is 4,000. Then 14, that is 7,000. 14 minus 7 is 7. And then 14 minus 5 will be 9. 9,000. 9,000. Here, I subtract each entry from this, from 9,000. So effectively, here, this will be 0. This will be 5,000. This will be 1,000. And this will be 4,000. S3, again, everything from 9,000. So this is 2,000, 3,000, 0, 2,000. And then S4 will be everything from 12,000. So the first one is 4,000. Second one is 0. Third one is 5,000. Fourth one is 6,000. 6,000 as such. That is S4. So maximum regret. We then pick the maximum for each product. So the maximum for product 1 is 9,000. The maximum for product 2 is 7,000. The maximum for product 3 is 5,000. And the maximum for product 4 is 6,000. Now, the maximum of the maximums. So, the maximum of the maximums is 9,000. But what is the minimum of the maximums? So we say thus the minimum regret corresponds to P3. Because of this, the minimum is 5,000. So we say thus the minimum regret corresponds to P3 and is 5,000 units. Hence, P3 for 5,000 units, because it's P3 for 5,000 units. B2, part B2. That was B1. Then B2, advice on the best course of action using the expected opportunity loss criterion. Expected opportunity loss criterion. Now, here we have to make use of the initial probability vector that was defined before. So in this case, for us to get the values as desired, what we'll do is now to bring in these components. And so the first part is P1. For P1, this is what we have for product 1. Product 1, this is how we are going to carry out its calculations. It will be 5,000 times 0.3. No, we use the initial. No, sorry. That is 9,000 times, it will be for product 1, it will be, just a minute. It will be 9,000 times 0.3, 0.4 times 0, 2,000 times 0.2. So using this and this, we should have for P1 is 9,000 times 0.30 plus 0 times 0.4 plus 2,000 times 0.2 plus 4,000 this, 4,000 this, because we are going this way. So times 4,000 times 0.1 plus 4,000 times 0.1. Now, if you work that out, you should be able to get 3,500. So it's upon you to try that in your own time. Then P2, for P2, we do the same thing. So it will be 7,000 times 0.30. So it's 7,000 times 0.30 plus 5,000 times 0.40 plus 3,000 times 0.20 plus 0 times 0.1. Now, if you work this out again, what you should get is 4,700. So doing that for P3 and P4, if we do that for P3, doing the same thing we have done to P1 and P2, if we do it to P3, what we'll be getting is 2,100. And if we work out for P4, what we are going to get is 2,600. That's what we have, 2,600. And we say the minimum expected opportunity loss criterion is 2,100, because you see that here we have 2,100, we have 2,600, we have 4,700 and 3,500. Now the minimum of this, again, we see it reflected in 3, the one we picked in 3 as such. So product 3 gives us that minimum, and so that corresponds to product 3. Product 3. Therefore, the best course of action is to choose product 3. So using EOL as well, it confirms that it is indeed product 3 which minimizes the regret. And now we have Roman 3 asking us, an expert has offered to provide perfect information at a cost of 2,500 shillings. Advise the management of the company on whether or not to acquire the perfect information. That is 6 marks. So marks. So what do we have? Expected, what we need to do here, expected value of perfect information, that is EVPI, is the difference between the expected value and uncertainty, that is with perfect information, and the expected value without perfect information, that is using the best decision based on expected values. So expected value and uncertainty becomes, so expected value under certainty is, we'll be having 14,000, which was the maximum for the first state, because you see, we had defined initial probability vector for the states. But now, realize that state 1, the optimum or the maximum value we picked was for 14,000. So we would say 14,000 times 14,000 times 0.30, 0.30 plus the second state we had 9,000. So that becomes 9,000 times the second probability that we had, which was 0.40, plus the third one again is 9,000 times the probability, which is 0.20, plus third bit we had now 12,000. 12,000 is the value we picked. So 12,000 times 0.1. Now, if you work out this well, then the value you should be getting is 10,800. 10,800. And that means that expected value without perfect information using the product with the highest expected value, i.e. P3. So expected value of P3, in this case, we had to be, so it's P3 that we picked. And if we picked P3, then we want to see what that particular information is by doing the same thing we did to the maximum value in each state. Now, in this case, we have already picked this. So we go with the values, defined in each state by product 3. So first, what we'll have is, the first thing we do is we had, now I've wrapped the initial table, and that initial table has information that should be useful, to me. So let me just get back and see. But in essence, what I needed to say without having to refer to it is that the expected value of P3, the expected value of this product 3, the expected value of product 3 will be given by 10,000 times 0.30. Again, these probabilities are wrapped. These are the initial probability vector that I provided. Then plus 8,000 times 0.40 plus 9,000 times 0.20 plus 7,000 times 0.10 times 0.10. Again, if you if you work out this, you should be able to get a value which is 8,000. It should be close to 8,700. 8,700. That's the value that you should get. And if that is the value that you are going to get, then let me rub this. In effect, what it means is that I now need the EVPI, that is expected value with perfect information. So my EVPI will be 10,800 that we had minus 8,700, and that should give you about 2,100. So what we say is that since the expert is charging 2,500 shillings, which is greater than the EVPI of 2,100, then the company should not acquire the perfect information as the cost exceeds the value of the information. As the cost exceeds the value of the information, that is cost info. Yes, that's what we have. So that is the end of my presentation. I urge you to go through it once again so that you follow through each and every step. Up to there, see you in my next video.